Hi everyone, today we're going to do lesson 3 of our systems unit. We're going to be solving equations by the method of called substitution. So far we've been solving our systems using graphical methods where we graph our two lines and then see where they intersect to and get that coordinate to get the solution. So now we're going to be doing it by a different method because sometimes graphing can take a long time, and this is a little bit more efficient. So here it goes. Okay, so again, here are the steps. I'm just going to go through these steps by using an example so you can read these after. All right, so it says consider the following system. This is example 1 in your book here. So here's our system of equations. So again, so far we've been graphing these equations, converting them into y equals mx plus b format, and then graphing them and seeing where they intersect. However, there is a little bit quicker way to do that, and here's the method. Okay, so we have two equations. I'm going to take the first equation and rewrite it in terms of x. Okay, so here's my first equation. Let me scroll down here a little bit. Okay, first equation is x plus 4y equals 17. I'm going to rewrite that in terms of x, so it's 17 minus 4y. Okay, my second equation is 2x minus y equals 7. And now what I'm going to do is I'm going to substitute, instead of this x, I'm going to substitute this over here, because from the first equation we get that x equals 17 minus 4y, and I'm going to put that into this x over here, and that's going to create a third equation that's going to look like 2 times, and then I'm going to just use a bracket here, 17 minus 4y minus y equals 7. What I've done here is I've eliminated one of the variables. If you look at our third equation now, the only variables I have are y and y here. There's no longer x and y, because when you have two variables like this, x and y, there's no way you can solve for both of them with just one equation. If you keep playing with this, you're never going to get a value for either x or y. Now, because we have two equations, we can use the information from one equation and substitute that into the second equation. And now, by doing that, we eliminated the x value, and now we can actually solve for y. So now it's going to be 34 minus 8y minus y equals 7. We're going to get 34 minus 7 on the left side here. That's going to be 27 on the left side, and I'm just going to go ahead and go 8y minus y is negative 9y. Move that over and get 9y, and then finally y equals 3. Okay, and again, I need to now that I have y, I need to get x, and now this is the easy part. All you do now is pick either one of your equations, 1 or 2, and substitute 3 instead of y. So we'll get 2x minus, and now instead of y, I'm going to put a 3 equals 7, and x is going to be 5 when you solve for x there. So that is the solution to this system here. X equals 5 and 3 equals 5. And if you actually go ahead and put that into this first equation, you're going to see that it should work out. So let's go ahead and verify that. I'm going to verify it in green here. If x is 5, so I'll take this first equation, and instead of x, I'll put a 5. Then 4 times y is 3, and hopefully that equals 17. Well, 5 plus 12 does equal 17, which means that both of these values will work for both equations. Again, if we graph this would be the point of the intersection point. 5, 3 would be your intersecting point. All right, now I'm not going to do this part B because it's saying to rewrite it, to do it using the same thing, rewrite it in terms of y. I didn't have to solve for x here. I could have solved for y and then substituted for y. It would have you would have reached the same conclusion. Okay. All right. Let's get into a few more examples here. So consider the example number 2. Consider the following system of equations. Again, I have two equations. Solve and verify using the method of substitution. So again, let me walk you through the steps. I have 4x. That's my first equation. 4x plus 3y equals 0. I'm going to have to solve for one of the variables here, and it's going to be 4x equals negative 3y, x equals negative 3y over 4. Okay, I've isolated x by itself, and I'm going to use that information to put it into the second equation, which is 8, and then I'm going to go ahead and put that x, instead of x here, I'm going to put whatever x is, but this is a little more convenient in terms of y, and that allows us to eliminate that x there. So negative 3 over 4y minus 9y equals 5. Okay, so now that I've done this, I basically eliminated my variable, my x variable, and I can go ahead and solve this. So this should be, let me cross this out, that should be a 2, so negative 6y minus 9y equals 5, negative 15y equals 5, y equals 1 over 3 negative 1 over 3. Okay, and again, I need to solve for x now, so I'm going to go ahead and plug or substitute. Sometimes you hear teachers say plug in. That's what they mean when they say plug in. You're substituting, instead of y, instead of variable, you're substituting in another value for that variable. All right, so let's go ahead and do that for either equation, either first or the second one here. So I'm going to go ahead and do that just to verify it for 4x plus 3y equals 0. So let me go ahead and solve for x here. And that's going to be 3 negative 1/3 equals 0. So 4x, that comes up to negative 3 equals 0. X equals 3 quarters. Okay, so there's my solution. My solution is a little bit awkward because of all the fractions. So it's 3 quarters, comma, negative 1/3. And that would be my intersecting point on the method. It says check here. Check the solution using a graphing calculator. Okay, let me pull that out just so we can do this. Check it. So again, when you're using a graphing calculator, you need to put everything in y equals, because that's the only thing the calculator accepts. So this first one here is y equals, let me go ahead and rewrite that. I need to rewrite both of them. I'll do it up here. So y equals negative 4 over 3x. That's the first one, and the second one is, let me just do this one. Y equals negative 8x, so 8 over 9. I'm doing this in my head just to save some time here. I suggest you guys write it out. Plus 5, or that should be a minus 5 over 9. Okay. So I'm hoping that once I graph these, this will be my solution over here. So let's go ahead and do that. Okay, the first one is negative 4. The slope is negative 4 over 3x. And the second one is 8 over 9 x minus 5 over 9. Okay, once I graph that, okay, it looks like it's very close to the origin, and I think I'm probably going to be very close to the right answer here, because I can tell both of these quantities are less than 1 over here. So let's go ahead and get my solution. Go down to the intersect. First curve, second curve, enter again. And there it is. Now these are fractions. These are decimals. So again, you need to verify this. And I must have made a mistake somewhere, because this should have been 1 over 3. 1 over 4, because that's a quarter, and I can kind of see that already where I went wrong, and that is right over here. When I multiply this out, this should have been negative 1, making this 1 over 4 over here, and that is 0.25, and this one is going to be 0.33 repeating, and that is what I get in the calculator. So always double check with the calculator to make sure you got your calculations correct, especially when you're dealing with these fractions, as it's easy to make a mistake. Okay, let's move on. Let's do another one here. Okay, now it gets a little bit more complicated. When you see something like this, okay, the first thing you should do is, let me move this over here, 5 2a minus 3 plus b. The first thing you should do is isolate the variable that's the easiest to isolate. Obviously, it's going to be easier to get b by itself than a, because a is buried in this bracket over here. So I'm just going to get b by itself. It's going to be 5 minus this whole thing, 5 2a minus 3. Okay, so that's my first equation. My second equation is 6a minus 2b minus 4 equals 20. And again, now that I have b, this has to go into here, and that's going to be a fairly complex equation. So make sure you get all your brackets out. So you have to really be careful. So now when I get my third equation down, it's going to well, first let me rewrite it using. I'm just gonna I'm gonna put these brackets. I'm gonna make big brackets here like this, and equals 20, and that way I have a minus 4 here. Now instead of this b, I need to put in all of this stuff over here instead of b. So I'm gonna get my bracket going, and I'm gonna go ahead and put this in there. So 5. Actually, the first thing I'm gonna do is I'm gonna simplify this over here, and that's gonna make it a little bit easier. So 5 minus 10a plus 15, and then it's gonna be negative 10a plus 20. So now it's a little bit easier to substitute all of this stuff in here. I have negative 10a plus 20, and that 20 minus 4, that's going to turn into a plus 16. Okay, so now I'm going to go ahead and get rid of that bracket. So, oops, 6a, again, always do the stuff inside the bracket, so that's going to be a plus 20a, and then negative 2 times 16 is going to be negative 32 equals 20. 26a equals 52, and I'm kind of confident that I got this correct, because 26 times 2 is 52, so a is going to be 2. Okay, now let's, again, you're halfway done, because you got to now get b once you get a. And again, to get b, all you do is just take that 2 and substitute it in for a in either of the two equations to get a. So again, I'm going to go ahead and do that here. So 6 times 2, I can do that in my head. Let me get rid of that there. So that's going to be 12 minus 2b plus 8 equals 20. 12, so that's 20 minus 2b equals 20. Those 20s are going to cancel, and b is going to be equal to 0. That's a little bit suspicious, so I'm going to go ahead and verify this algebraically. Okay, let's see if that works for the first equation, which is 5, and then 2a, which is 2, so 2 times 2 is 4. 2 times 2 is 4, so 4 minus 3 in the bracket, plus b, 0, equals 5. And that is correct, actually, because 4 minus 3 is 1, so 5 times 1 is 5. 5 plus 0 is 5. That works. Okay. All right, moving on. This one's, again, so this is, the point of this is a bit of an enrichment thing. So, again, you need, if you have two unknowns, such as a b and an a, so if you don't know two variables like x and y, okay, in order to solve that, you need two equations. So for as many variables that you don't know, that's how many equations you need. So if you have two unknowns, you need two equations. If you have one unknown, well, you need one equation. For example, if x plus 3 equals 10, well, we know that x equals 7. We have one unknown and one equation, so we can solve that. This one over here, this is a little bit difficult now, because now we have three unknowns, x, y, and z. So we need three equations to solve all of those, and this is going to get a little complex. This is a bit of a advanced lesson, which is not going to show up on your test. So I'm going to go ahead and show you this in class if you're interested. All right. Again, thanks for watching, guys, and see you next time.